All right, ladies and gentlemen, today we are going to be dealing with completing the square. We get to complete some squares. It'll be amazing fun. Many of you may already know how to do this, but before we go too far into it, I want you to multiply out these binomials. Okay, so when you look at this, x plus 2 quantity squared, we've talked enough about it this year that I'm just going to remind you that this is x plus 2 times x plus 2. Hopefully you already remembered that. And hopefully you can multiply it out fairly fast. Okay? And the same thing here. And then here. All right. So let's get those multiplied out really quick. The square. Completing the square is going to be another way that we can use to help us get to a point where we can solve for quadratics. Okay, so x plus 2 quantity squared. Hopefully everyone got x squared plus 4x plus 4. X squared plus 6x plus 9. And x squared plus 8x plus 16. Now, looking at those numbers right there, what are the patterns that you have when you have a binomial squared and then you multiply it out to a trinomial? Binomial meaning two terms and it's squared, being multiplied out to a trinomial. What are some of the patterns we see up there? Matt, what's one? Okay, so your b term is always twice the non-variable number. So that's 4 and that's 4. And that's, if you double that, you get that. If you double that, you get that. Okay? Yeah, Dallas. No, we're not to the bottom yet. Okay, so we're talking up here. How do we get from here to here? Let's go to Walsh real quick. We'll come back. Okay, half of your b term is the square root of your c term. Okay? The square root of that is half of that. Square root of that, which is 3, is half of 6. Square root of that, which is 4, is half of that, which is... Okay, good. Emily. Good. Your c term is always whatever your constant is here, squared. So 2 squared is 4. That's how we get the 2 by 2. Okay. So we can apply some of those things down here. So if we know our non-variable or our constant in our binomial, so if our constant in our binomial is always our back term, well, that would be nice if we knew this number. Okay? And if we always know that this number right here is always, how's it related to this one? It's double it, right? So if I cut that in half, I get that. Okay, so Dallas, how do I get from here to there? Divide the b term by 2, and it gets me 9 there. Okay? And then we know if we square that, we get that. We get our c term. Okay, that's how a binomial square works to give you a perfect square trinomial. Okay, that is called completing the square. You are completing a perfect square binomial. Okay, now we obviously have to put other things in here like n, the square root of that, which we didn't even talk about up here. Okay, the square root of this is always that. And we have to put a plus. How do we know? Because that was positive. Well, what if this is negative? Let's see. So let's cut this in half. What do we get? 12. And square it to get 144. Okay. And then this is k. And are we sure it's minus 12? That didn't make any sense. K times k is k squared. Negative 12 times negative 12 is positive 144. Negative 12k and negative 12k is negative 24k. Very good. So this is minus. You just take this sign. Okay. Can this ever be a negative back here? Talk to your neighbor. Why could this never be negative? Okay, volunteer. Why could it never be negative? Yes?
When two numbers are a square root, it means they're the same number, and two negatives and two negatives or two positives always equal a positive.
Very good. Yeah. Yeah, anytime you square a number, you get a positive number, whether it's negative or positive. So there's no way to get a negative back there. Okay? So in this case, when we square negative 12, we get positive 144. Okay. I want you guys to finish up this page real quick. We get about a minute to work together. All right, let's check them. Hey, cut this in half. We get 1/2. So now we have x minus 1/2. Now notice the 1's up here, right? And then when I square it, what's 1/2 squared? 1/4. Let me zoom in there so we can see that a little better. Okay? This becomes 1/4. Okay, for those of you who are like, huh, how do you do that? Well, remember, 1/2 squared is just 1 squared over 2 squared. Okay? 1/2 of this, 10. So we get x plus 10, and square it, we get 100. Half of this, 1.5, or how about, you sure it's 1.5? That is 1.5, isn't it? So when we take half, can we write it as 3/2? Yeah, let's leave it as 3/2, okay? If you want to put it as 1.5, I guess you can, but you guys are anti-fractions. I'm not an anti-fraction type of guy. Okay? Then when we square, we get 9/4. Some of you would say like 2.25, but all right. I would be fine either way, I guess. Since it terminates, it's okay. All right, this one is x plus 2 and 4.
It finally makes sense why a fraction is like the equivalent of a decimal, because a fraction is just like that number divided by that number, which is a decimal. Good job.
Okay. Well, moving on. All right. Hey, let's go ahead and take a look at your student journal, page 58. All right now, 1 through 3. You guys get a few minutes to work together on them. Off you go. 1, I want you solving these using square roots. Okay? Not factoring. Use square roots. Hey, so what I expect is that you guys struggle through things that you don't quite understand sometimes. Actually, a lot of times. Okay? It's not every time. But you should be able to look at that and recognize that is a perfect square. We just talked about them, right? That can also be written as x plus 2 quantity squared equals 2. Right? So this is the same as that. And from that point, how do you use square roots? Oh. Yeah, you don't unwrap the present. Very good.
Boy, everything you say is great, except when you say you have a test. But other than that, it's 10 out of 10 stuff.
Thanks. There we go. Okay, so take the root. They cancel. Subtract 2 from both sides, and we've got it. Pretty radical problem, if you ask me. So give number 2 go. Joking. Okay, can I have your attention up here? How many got t minus 20? 20 squared equals 300. Okay, take the square root, we get t minus 20 is equal to root 300 plus minus style. And then add 20. T equals 20 plus minus root 300, which we can then simplify to t equals 20 plus minus root 100 by 3, right? So that's 10 root 3. Can you combine 10 and 20? No, this is counting roots. This is saying I have 10 of these roots. This is saying I have 10 single units. They're adding different things.
So you can't put the 20 after that, right? Because of the plus and minus. So it has to be the 20 before.
Yeah, you'd want the 20 before. Okay, you guys, the other thing is what you're going to have, now that you have this factoring or this tool completing the square in your bag, what you have to start doing is asking yourself, perfect square? Yep. Perfect square? Yep. Okay, the square root of this is t. The square root of this is 20. That times that is? No. Square root of that is? I'm sorry, I asked you wrong. Square root of that is t. Square root of that is 20. What is 20 times t? 20t doubled is 40t. That's how you should be able to recognize perfect squares. So if you look at the front and back and go, whoa, those are both perfect squares, then see if when you multiply their roots together and double it, if it's the middle. That tells you it's a perfect square as well. So like when you're looking at this, what's the square root of this? 3w, and square root of that is? 3w times 1 is 3w, doubled is 6w. So this is a perfect square. Okay? All right. Let's move on. Did everyone try 3?
Nope.
Well, finish it. I'll give you a shot at it. Okay. So some of you are going to get further than others on this. You're going to get to a point, some of you, and you're just going to be completely lost. Okay? So let's check it out. If I try this, this becomes 3w plus what? Uh-oh. Everyone good? It's 1? Yeah, it's square root of that, right? Okay, 3w plus 1. All right. From that, we take the root. Well, first, how many made it that far? Okay. Square root of the front, square root of the back. Okay, that is legal. As long as you know it's a perfect square. If you know it's a perfect square, take the square root of the front, square root of the back, and put a squared symbol. You're done. Okay? All right. Now, some of you, as here in conversation, after you take the square root of both sides, you get to here, and you go the plus minus. We good there? Okay. From that point, what do? Subtract 1. Trying to get w by itself. Subtract 1. 3w is equal to negative 1 plus minus root negative 18. Yep, it can be. I'm not going there yet. Just going to get w alone first. What now? Divide by 3. W is equal to negative 1 plus minus root negative 18 all over 3. Now notice everything's over 3. Now what I've done is I've done all the stuff you know how to do. Like none of that is kind of, well, maybe the completing square is brand new. Okay? But from here, now you have to deal with the simplifying. You can't divide anything. Can we divide 3 and 18? No, one's inside, one's outside. Okay? Can't do that. All right? Our student section would be yelling at the other team. Okay? Negative 1 plus minus the root of negative 18 becomes? So for those of us that are a little off on it, that's negative 1 times root 9. Negative 1 times root 9 times root 2. Thank you. Okay, 3i root 2. You guys, here's where, well, let me finish this real quick. This is my answer, okay? Now, can I cancel the 3's? Well, the answer is yes and no. You can, but if you do that, then you have to write it differently. Like if you cancel these 3's because they're both out, you have to say, well, this part's being divided by 3 as well. So that's negative 1 over 3 plus minus I root 2 then.
So would that be an
Okay?
answer?
This would be a fine answer as well. But you can't just eliminate the 3 and put, you cannot do this. You cannot say negative 1 plus minus I root 2. That is not okay. We frown on that. That's bad. Okay? Don't do that. Yes? Over here? Oh, no, because multiplication carries division through. So since there's no addition or subtraction in there, you don't have to. Rory? You just have to have it where it was here. Okay? So the plus minus just carries down with it. Yeah?
Do you have a preference which version you want?
Doesn't matter to me. Yeah. If you could take 3 out of both parts, then I want you to. Otherwise, you can. It's up to you. Okay? We good? Here's why a lot of you will make a mistake here. Here's why a lot of you will make a mistake here, because many of you don't want to write this piece down. You're like, whoa, hold on, you want me to write 1, 2, 3, 4, 5, 6, and then if you count those multiplication symbols, that's like 7, 8 things, McCoy. I mean, seriously. And then there's like a negative sign in there. Come on. Okay? All right, I get that it's writing a little more, but dude, if you want to get it right, rather than staring at your paper and looking like you're having some kind of major problem because your face is all going contorted and weird, you know? All right. Moving on. Take a look at number 4. Find the value of C that makes the expression a perfect square. 4 through 6, you guys get 1 minute. Hey, so really we're trying to find that perfect square, right? So square root of this is y. Square root of this has to be something that I multiply by 2 to get that. What is it? 7. You just cut this in half. It's 7. So this is 49. Cut this in half. Whoa, that's tougher. 8.5 squared. I know it's between 64 and 81. 72.5. 72.25. All right. Very good. I'm not going to do the last one. Moving on. 7 through 12. Solve the equation by completing the square. All right. Off you go. Okay, how many have run into the problem? You're like, dude, those are easy. It's just like number 1 through 3. Yeah, so we got a problem because this isn't a perfect square. That's why we call it completing the square. Like, it's not a square yet. Get it? And you have to complete it. So this is where we get to, like, the real fun. Okay? So I'm going to show you the way I do it. The book walks through it a bit differently, but I think this is easier and better because I do it that way. R squared minus 6r is equal to what? It's equal to 2. Now, how did I get that? I added 2. Now, why would I do that? Because now I have an empty seat on my right. Okay? Here's the empty seat. And that empty seat is going to be filled with a plus because, as Quaid pointed out, or excuse me, Walsh. I don't know why I call you Quaid. Okay? No, Quaid. I must have had a Quaid one time. Okay? So, this empty seat right here, this empty seat has to be positive because it's a perfect square. And when I cut this in half, I get 3. And I square it, I get 9. And whatever I add to this side, I must also add that same seat on this side, which makes this 9. Whatever I add here, I have to add there. I have completed a square here. I have made a perfect square trinomial, which I now write as a binomial squared, which makes that 11. Yes? Yes, it would be negative. Thank you for pointing that out. I just got so excited about being positive. Okay, that should be a -3. Thank you. Was that what you were going to say? Okay. Everyone with me? Okay. And so from there, now it's just like the top problems. Okay? Now you do what? You take the root. And then we add 3. That is so neato burrito. Man. Yeah. Yeah, that's a good idea there, Walsh. Okay. You wake up on Christmas morning and find one in your stocking. All right. Everyone try number 8 on your own. All right, let's check it. So x squared plus 10x plus our extra seed on the right is equal to -28 plus the extra seed on the right on that side.
So, wait, I don't even understand. I guess I do understand. It's just weird. Why is there 28 just chilling? Like, just because?
Well, because not everything's always perfect. Okay, how many got it? I think that's pretty cool. Okay, any questions? Yeah, Dallas. Sure. Hey, yeah, you guys, I need your attention back up here. The way the book goes through, and a lot of people go through it this way, is they just manipulate this to become the perfect square. So like they just say, well, I know it's going to be 25, so I'm just going to move 3 over here. And that's fine. Or they just leave the 3 there. They just break it into it. I just find it easier it's easier for me to understand to move this out and then just make it a perfect square. That's easier for me. So if you can think through it that way, that's fine. Yeah. All right. Yeah, keep on going. Number 9. We love it. Okay, before you guys finish this one, can anyone give me a strategy? Like, what are you doing? Yeah. Holy moly! All right. All right. So I think that's the way Mackenzie started. She did distribute and then binomial form, which I think she meant to do completing the squared. Is that what you're saying? Then she kept going, and that was good. But, all right. So from there, that is y plus 1/2. So we square it. This is 1/4. All right. Makes this 1/4. Remember, you're squaring this piece to get that piece. All right, that's the perfect square, which makes that side 1. Isn't that convenient? So y plus 1/2 is equal to the plus minus root of 1, which is, that's actually just 1, plus minus 1. So y is equal to -1/2 plus minus 1, which you actually have to do the math on that.
Do you ever, like, just go out in
No. I try not to go out on Halloween. It scares me. You had negative 1/2 plus 1 in terms of halves is how many halves? 2 halves. So I'm going to call it 2 halves so I can add those and feel good about myself. Okay, because I'm adding fractions now. That's 1/2. All right. And then I have negative 1/2 minus 2/2, which is negative 3/2. So my answer is y is equal to the set containing 1/2 and negative 3 halves. And I didn't even write it in numerical order, which kind of bothers me right now, but I'm not going to erase because I can't because it's a pen. Huh? Not required. It'll make me feel happy. But, yeah. You're good? We love it. All right. Well, let me give you, take a look at number 10 real quick. Just so that we're clear. Number 10, tell your neighbor what you can do to that to make it a little easier. Okay, what can I do? Divide by 2. Now, when I divide by 2, what happens to the 2? Doesn't disappear. You're factoring out a 2. It doesn't disappear. It's not gone. You're not taking a 2 out of that because you don't have anything. You can't take a 2 out of that because you have nothing. Okay? So that is 3. And then you can try some other stuff with it. Okay? So from that point, you could try to approach this problem. The other route, and probably I would say the easier route, I just want to see if you guys would divide by 2. I'd say the easier route to deal with this is I would call, and you're still dividing by 2, but I would move that 6 first. Because if I move the 6, now when I divide by 2, what happens? Now you're getting rid of it. Yeah, man, and that problem looks a lot nicer. Okay? All right, finish from there. That's where we'll pick up tomorrow. Okay? I want you to go through number 13. Let's go ahead and finish that page.